Great. Recording is rolling. Hello, everyone. I'm here with Dillon, one of our tutors, and he also took this class last year. We are going to talk to you a little bit about ourselves and machine learning. So to start with, Dillon, could you say a few words about yourself?
Yeah, okay. Hello, everyone. I'm a fourth-year undergraduate student at ANU. I took this course last year at Lexing Xie. My research interests lie mainly in machine learning and artificial intelligence. Nice to meet you all.
Great, thanks. Right, so I'm Lexing. I've been doing research in machine learning and social media at the ANU for about 10 years. I've been teaching this class since only last year, and my group have been, I guess, learning, developing, and using machine learning for more than the last decade, right? So I look forward to learning, to the learning journey, to going through the learning journey with you this semester. Yeah, my second question is, right, your favorite machine learning algorithm or model. So Dillon, would you like to share?
Yeah, okay. First I'll talk about my favorite one that's done in the course. My favorite model is neural networks because they're so easy to understand, but they're used in everything, all the models, most models in machine learning. In my research, I'm working in graph neural networks, which build on neural networks, which I think are also pretty interesting because you also have to account for structure between your data, which may not exist in normal neural network models.
Thanks, Dillon. Indeed, yeah, neural networks are very expressive models, and representing graphs is a really interesting challenge that we don't directly tackle, except in the graphical model section, but in their graphs mean something else, representing dependencies rather than representing entities and their relations. Well, talking about favorites, I'm just going to pick the machine learning model that I started my own research with way back when I started my own PhD. It was hidden Markov models. So I read a tutorial about the estimation and inference of hidden Markov models. So basically, a graphical model that's shaped like a chain that has many uses. Has been developing for a long time on speech recognition. Before I used it, I was using it on video content, and at that time that was relatively new and cool. It was, yeah, shortly after year 2000. So just shows, I guess, how much time has elapsed. I like it because there are principled and efficient algorithms. We will not directly cover it in this class, but yeah, the foundations for doing inference and learning are actually in the graphical model section. So since I have learned and did my first piece of research with HMMs, the inference of graphical model also progressed a lot. For example, what you learn about message passing wasn't there when I learned graphical model the first time. We were doing junction trees, which are yeah, still useful, but there are better things now. Moving on, so what advice do we have for learning machine learning, and in particular for SML as a class?
Yeah, a few advice tips. First thing to keep in mind is SML is a really hard course. You will have to work really hard if you want to get the most out of the course. More specifically, talk about how I survived this course. SML is a very breadth and depth course. So it covers a lot of content in 12 weeks and goes into a lot of detail as well. So you want to keep up to date every week. You want to use lots of resources outside the lectures, slides, read the textbook, maybe consult Wikipedia or other blogs online And yeah, also get started on assignments very early. They're not easy compared to maybe some other courses. And yeah, all the best in your study.
Yeah, thanks, Dillon, for outlining the challenges and your ways of tackling it for the student. I feel like since it's been a while since I've learned this material myself for the first time, but here's from the instructor's perspective, here are my recommendations, right? So the difference among, I guess, machine learning in CS and statistics is the more emphasis on the computational aspect. So programming is important. I would say the lectures do not address that aspect. Most of them, oh, well, we address it from the mathematical and computational complexity analysis point of view, but we do not address the programming aspects. So that's what the tutorial will help you with. And yes, get started with the assignment early. And this year, for example, assignment 1 is we think it's a lot more interesting and somewhat more challenging than last year's assignment 1. I hope you will enjoy it. Do start early. Right, so assignment is an integral part of your learning as well. Don't treat it just as a sort of evaluation. I feel, right, last year, a lot of students seem to have had some fun making the video assignment. It's an 8-minute presentation. I hope you will do as well. There were many good examples from last year. I would say that the different parts of the course assess different things, right? So the assignment and tutorials will cultivate and test your ability to solve a bigger problem in a longer period of time, but exams will essentially test your analytical reasoning in a limited amount of time with one little bit of challenge at a time. There are many resources provided in this class and also available online freely nowadays outside of this class. Hopefully, I think the lecturers and tutors will give you the guidance on how to navigate them. And if you have doubts, I think, or questions, I think ask the tutors or post on Piazza. I will also have contact hours myself that you could ask one-on-one questions, usually after lectures. So hopefully with the combination of different methods, we can cater to such a large and diverse class studying from all over the world. So the last question I have for Dillon is, what is one common misconception about machine learning?
Okay, I'll talk about one misconception that you see like in the media and like with most people. And you might also see like some students, like most people think machine learning is like very intelligent. Like you see like machine learning models like treat like humans in like games. You can like make some weird predictions about your Facebook activity and like recommend ads to you, which you find very like weird, but like most people don't understand that machine learning models aren't all that like intelligent. They're just a lot of like hard work and engineering that has been put to like do one specific task like very well. And analogy I can give to this is like medicine and vaccination. Like for example, you can have like a vaccination which like targets a specific like disease like COVID, but you don't have like a single vaccination or like medicine that can solve like all the world's problems at once. The same thing in machine learning. You have specific models for specific tasks. There's not one like solves all kind of model out there. And yeah, I guess that's one misconception. Machine learning is not that intelligent.
Thanks, Dillon. That's very nice. Machines are diligent in crunching through data, but they're not that intelligent. So I fully agree with you, and we'll go through some of these throughout the semester as well. I will borrow a quote to maybe conclude our chat. which is from Andrew Ng. He once said that worrying about AI and machine learning taking over the world is like worrying about overpopulation on Mars when we immigrate there. Right, so we'll leave it there and stop the recording.